Okay, let's unpack this. You've handed us the source material, and you want to know the most important nuggets, the hidden insights. Basically, the stuff that gets you truly informed without drowning in details. Welcome back to the deep dive. Today, we're diving into recommendation systems. Specifically, we're looking at how they operate in, well, the very dynamic tech landscape of China. We're going to explore the engines driving what gets suggested to you on platforms like, e-commerce giants and music streaming services. And this is all based on this expert source material you've shared. Our mission, to get a clear picture of the technology shaping your online world over there.
And it really is mission critical these days. Recommendations aren't just a nice to have anymore. They're really essential infrastructure. They're the key to cutting through just overwhelming choice, whether you're looking for, say, a product on a huge shopping site or maybe a song in a library of millions. Get recommendations right, and you dramatically boost how much users engage, how much they spend. They're just everywhere. Shopping, video, news, and definitely music.
Right. And the source gives us some excellent real-world examples to dig into. We'll be looking at the massive e-commerce player, JD.com, and then we'll kind of shift gears to music streaming with examples like QQ Music and NetEase Cloud Music. Just a heads up, though, this source is, well, it's so dense we actually had to split it. So this is part one, focusing on EC and music. We'll dedicate another deep dive soon to the source's insights on Douyin, China's TikTok, because, frankly, that platform's recommendation system is a whole different beast. So let's start simple. When you think about recommending something based on what other people like. What's the foundational idea there?
Well, what's fascinating is how intuitive the starting point actually is. It's called collaborative filtering, CF for short. The core concept is basically just people like you like this too. It's pretty simple at its heart. Think of that classic line we've all seen, probably on Amazon. Customers who bought this item also bought.
Yeah.
That right there. That's pure collaborative filtering in action.
Okay, so if I buy like item A and item B, and lots of other people who bought A and B also ended up buying C, then the system figures, hey, this person might like C as well.
Exactly. The mechanism, like the source describes it, is essentially clustering users, grouping them based on their past actions, buying, browsing, rating, whatever. So imagine a group of users who've all interacted with items A, B, C, and D. Now, if you come along and you've interacted with A, B, and C, the system basically says, aha, you look like these folks over here.
Right.
And because that group also liked D, well, it recommends D to you. It's kind of like drawing a map of user tastes and finding the items that sit close to your little corner of the map, because other people in your neighborhood, so to speak, liked them.
That makes total sense intuitively. But does it actually work perfectly? In the messy real world, like I sometimes buy stuff for my job that, honestly, I personally hate.
And that's exactly where the rubber meets the road. Because simple CF, it hits some pretty significant walls, especially at the kind of scale we're talking about in China. The source really flags the problems. Accuracy is the first big one you hit. Just buying something, like your work example, doesn't really mean you liked it, does it?
No, definitely not.
Did you finish that book? Did you use that gadget more than once? Simple CF, if it's only based on purchase history, it assumes bought equals liked. And that's, well, it's often a terrible assumption for accuracy. To get better, you have to add more data. Things like user ratings are crucial. How long you viewed an item? Did you buy it again? The source really points out how critical those 5-star ratings are, not just for other users, but because they give the system a much stronger signal about your actual preference. It makes the recommendations specifically for you much better.
Okay, so you pile on more data points,
Yeah.
trying to get more accurate signals about what people actually like.
Right, but then that leads you straight into the second problem. And arguably, it's the biggest one for simple CF computation cost. Just think about it. Hundreds of millions, maybe billions of users, all constantly buying, browsing, rating.
Yeah.
The system needs to constantly recalculate those user clusters, those similarities. It's nonstop. Now, add more data points, browsing history, clicks, how long they lingered on a page, the calculation required for each user, potentially in real time, it becomes absolutely immense. Astronomical.
Wow.
At some point, you just can't do it fast enough or accurately enough for everyone without building, a supercomputer the size of a city block. So you're forced into this difficult trade-off, right, between how fresh and accurate the recommendations are and how quickly the system can actually deliver them.
Okay, so simple collaborative filtering. Great starting point, maybe, but it kind of breaks down at scale. You've got accuracy issues. Buying doesn't mean liking, and these crippling computation needs. This is where the source says things evolve, moving towards machine learning to solve these problems, right? getting smarter, not just bigger.
Exactly. Instead of just trying to perfectly map every user to every other user, the next step is using machine learning models to get, well, smarter about the predictions themselves. And the source identifies ranking learning as a major trend being adopted by platforms in China right now. It's a big deal.
Ranking learning. Okay, what's the goal there?
So the goal shifts. It's not just finding potential items anymore, which CF might give you this huge, messy list of possibilities. Instead, it's about taking a list of candidates and effectively ranking them. Which one is most likely to be number 1, number 2, number 3, all the way down. You extract this broad pool of possibilities, maybe from CF, maybe from bestsellers, promotions, whatever, and then a machine learning model predicts the best order for you. The power is really in prioritizing the best candidates from that large pool.
Okay, so you're not just finding a list, you're finding the best ordered list for that specific user at that moment.
Precisely. And the source highlights something really fascinating here, almost a paradox, when you try to use standard machine learning error measurements for this ranking task. Think about predicting something simple, right? Like how many beers a bar might sell based on the temperature outside.
Okay, hotter day, more beer.
Right. You collect data points, temperature, and sales, homing. You plot them on a graph, and you draw a line that minimizes the average distance between your line and the actual data points. This typically uses a standard error measure, something like sum of squared errors. You're minimizing the difference between your predicted value, the sales number, and the actual value.
Makes sense. Get the line as close as possible to the dots.
Exactly. Now imagine you have a list of items, and you're trying to predict how much someone will like each one, giving it a score, say, 1 to 10. If you use that same standard error measure, you might train a model that gets predicted scores very, very close to the true liking scores. The overall error could be tiny.
So it looks good on paper.
Looks great on paper. But when you take those predicted scores and use them to rank the items from best to worst, the order could be completely wrong. The item you predicted as like an 8.1 might actually be their absolute favorite, the true 10.
Yeah.
And the one you predicted as an 8.5, maybe slightly higher, might be something they only kind of like, maybe a 7.
So minimizing the error on the score itself doesn't actually guarantee you get the order right. That is a paradox for ranking.
Exactly. And this is why ranking learning uses a different kind of error measurement. The source mentions things like cross-entropy error. Instead of just penalizing the distance from the true score equally, this type of error heavily penalizes large mistakes in the ranking. Like predicting the item you'd absolutely love most ends up way down at the bottom of the list. That's a huge penalty. But it's more forgiving for small errors, Items that are ranked maybe slightly out of place but still near the top. It pushes the model to focus on getting the relative order correct, which is what actually matters for a good recommendation list. Think of it like scoring a competition, right? You care much more about who gets gold, silver, and bronze in that order than the exact decimal points on their individual performance scores.
That makes it much clearer. Yeah, you want the podium right, even if the predicted times are off by a tiny bit. So where do we see this kind of thing in action? The source points to JD.com as really leveraging these techniques in China.
Yeah, JD.com is presented as a prime example. They show how platforms combine that initial collaborative filtering idea for, like, candidate generation with this more sophisticated ranking learning. They apparently have a pretty detailed 5-step process for serving recommendations.
5 steps. Okay, walk us through it.
Sure. It starts with extraction. This is where they just pull together a huge list of potential items. Could be from basic CF, could be popular items, things on sale, stuff the user has shown even a tiny bit of interest in before. Cast a wide net.
Got it. Grab everything potentially relevant first.
Then step 2 is pre-filter. Before they waste time ranking this enormous list, they quickly get rid of things you definitely don't want to see, like items you already bought, or things that are out of stock that's super frustrating, right?
I'll take that.
Or maybe low-rated products, inappropriate content. Basically, clear out the obvious junk you don't want to waste computation on.
Okay, clean up the initial list. Then what?
Next is the core ranking step.
Yeah.
This is where their advanced ranking learning models kick in. They score and order the remaining viable items based on predicted user engagement or likelihood to purchase. This is the heavy lifting.
The magic happens.
Kinda, yeah. Then that's followed by post-filter. They take that ranked list and refine it a bit more. Maybe remove items that are too similar to each other near the top. You don't need 5 versions of the same blue widget. Or maybe group things nicely by category.
Okay, fine-tuning the ranked list.
And finally, step 5 is adjustment. They make final tweaks to ensure the list you actually see isn't just like 20 slight variations of the same phone case. They adjust for a variety across categories, using the rankings, but ensuring a more diverse, maybe more engaging final list.
Wow. That's a surprisingly complex pipeline. Just to show me a list of products.
Yeah.
How do they even know which ranking model works best? Or which filter is the right one?
Right, and the source emphasizes this. At JD.com and other leading platforms, this whole system is under constant scrutiny. The key is A/B testing.
Yeah.
Relentless A/B testing.
So trying out different versions on different users.
Exactly. They are perpetually running experiments, show random groups of users slightly different versions of the recommendation algorithm, maybe a different ranked model, a tweaked filter, and then they rigorously measure which one leads to more engagement, more sales, or whatever key metric they care about most. It's just this ongoing, intense race of refinement and optimization.
Okay, so that's the world of recommending products, driven heavily by user behavior, past purchases, and then these sophisticated ranking algorithms. Now, the source pivots us towards music streaming, where, the challenges and maybe the solutions look a bit different. And it gives us this quick, interesting historical tour of the music scene in China, from the early days of, rampant piracy
Oh, yeah.
to what the source calls the enclosure wars, the big tech companies like Baidu, Alibaba, Tencent, BAT, battling to lock down exclusive rights to music catalogs.
Right. And that history is really crucial context because it shaped the current landscape we see today. After years where users basically got used to free music through piracy, and then you had this period where the big players, especially Tencent and NetEase, battled fiercely over exclusive licenses, the market eventually consolidated. Tencent is pretty dominant now, but the competition shifted. It wasn't just about who has the most music I can't get elsewhere anymore. It became who gives me the best experience with the music they do have. And recommendations, especially those personalized radio features, became absolutely central to that user experience battle.
Right, the play me something I'll like button.
Exactly. And this is where content-based filtering really comes into its own. Instead of saying, users who like this song also like these other songs, it asks a different question. What other songs sound like this one? It's recommending based on the inherent characteristics of the music itself. This is perfect for building those infinite personalized radio stations.
So analyzing the music, not just the listeners.
Precisely. And the classic historical example the source brings up here is Pandora's Music Genome Project. Remember that?
Vaguely, yeah. They had people listening to songs.
They had actual musicologists painstakingly listening to songs and manually tagging them across hundreds, literally hundreds, of attributes. Things like, was it acoustic? Was the singer female? Was the mood melancholic? What instruments were used? They built this kind of musical DNA for each song to find similar ones. But just imagine the sheer human effort involved. The source mentions they were spending like 15 to 30 minutes per song doing that tagging.
That's incredible detail, but
Yeah.
completely unscalable for a library of tens of millions of songs that's growing every single day.
Exactly. So the modern version, like Plex's Supersonic, which the source mentions, is AI-driven. It's algorithms doing the listening. The software analyzes the audio itself, the waveform, the rhythm, the harmony, the timbre. It extracts dozens of technical parameters to calculate how similar two songs sound objectively. This allows them to automatically build those radio stations based purely on audio similarity. It can cross genres or artists effortlessly if the underlying sound matches.
Okay, so AI replaces the musicologist for scalability.
Pretty much. And we see the Chinese services adopting these kinds of ideas. Tencent is doing content tagging, apparently even looking at its associated music videos, PVs they call them. NetEase Cloud Music, though, has a particularly insightful approach mentioned in the source, especially with its radio service. They deliberately choose to focus only on your very recent listening history to drive those radio recommendations.
Only the last few songs. Why?
It's not just a technical choice. The source suggests it's a strategic bet on user behavior. NetEase seems to have recognized that your musical taste isn't static. It changes dramatically throughout the day or week based on what you're doing or how you're feeling.
That's true. My workout playlist is very different from my evening chill music.
Exactly. What you want to hear when you're driving to work is different from when you're relaxing later. By focusing only on the last few songs you played, they aim to capture your current, specific mood or context. And then they recommend songs that fit that moment, rather than recommending something based on, say, a genre you happened to binge 6 months ago. It's a really sharp insight, optimizing for the here and now of music listening.
That's clever. So, okay, we've looked at recommendations based on what other users, like that was collaborative filtering. And then recommendations based on the characteristics of the content itself. Content-based filtering, like analyzing the sound of music.
Yep, those are two major pillars discussed in the source, big approaches. But it does make it clear there's actually a third, fundamentally different approach out there as well.
And let me guess. That third approach is the one powering those incredibly addictive, almost spooky recommendation loops in short-form video platforms like Douyin, right? TikTok's counterpart.
That's the one.
The source apparently describes it as operating on completely different principles. So, okay, sounds like we'll definitely have to save that deep dive for our next session focusing on this source. All right, so to bring this part to a close again, what really stands out from this section of the source is just the sheer sophistication and, frankly, the competitive intensity driving recommendations in Chinese tech. It's clearly not just guesswork. It's these complex pipelines combining collaborative filtering, advanced machine learning like ranking learning, content analysis, all fueled by absolutely mountains of data and this relentless cycle of A/B testing you mentioned. Like a constant battle happening invisibly behind the screen, all aimed at capturing your attention and predicting your very next click or listen.
Yeah, it really is. And maybe if we step back and think about the implications, a system's this powerful, this focused on predicting your next action, it does raise a question for you as the user. When recommendations get so finely tuned to what you've liked before, are you being expertly guided to things you'll genuinely love? Or are you maybe being subtly confined to a kind of filter bubble, one that limits your exposure to anything truly new, truly unexpected? How does that impact your own journey of discovery online? Something to think about.